Factoring trinomials of the type x squared plus bx plus c. The learning objective is to factor trinomials of the type x squared plus bx plus c by examining the constant term c. So let's look at our key terms for this lesson. The first one, in the expression ax squared plus bx plus c, a is called the leading coefficient. So leading coefficient, and that is just going to be the number part of that term. Number two, a blank polynomial cannot be factored further. This would be prime. Just like we have prime numbers that only have factors of one in itself, we could also get prime polynomials that cannot be factored. 3. When the constant term of a trinomial is blank, the constant terms of the binomial factors have the same sign. Well, this would be positive. In order to get a positive product, you have to either multiply a positive times a positive or a negative times a negative, so that's what that's referring to. And finally, when the constant term of a trinomial is negative, the constant terms of the binomial factors have opposite signs. So now let's look at factoring trinomials. Now we've already looked at factoring involving greatest common factor. So that's the first thing you should always look for when you are factoring is, do I have a GCF? So in my problem I have x squared minus 8x plus 16. So when we are factoring trinomials, we want to focus in on that last term, which is going to be our constant. So in this particular problem, it's positive 16. So we need to look at factor pairs for 16. So things that multiply together to get 16. So what I like to do is just make a list. So we have 1 times 16. We could have negative 1 times negative 16. Because a negative times a negative is positive. We could have 2 times 8, 2 would be negative 2 times negative 8. 3 doesn't go in. We could have 4 times 4, and we could have negative 4 times negative 4. So these are all the different pairs of factors that would get us 16. Now we are going to look at the sums of those factors, because in a problem like this where our leading coefficient is 1, remember there's always an invisible 1 right here, then we can find factors of 16 that add to be negative 8. So here are all of my choices. We've already listed them. Well, if I add 1 and 16, I get 17. And if I add negative 1 and negative 16, I get negative 17. Remember, we're going for negative 8. So if I add 2 and 8, I get 10. Negative 2, negative 8 is negative 10. So I haven't found it yet, but it looks like I'm getting closer. If I have 4 and 4, when I multiply I get 16, but when I add I get 8. And negative 4 and negative 4, I would get negative 8. So it looks like my last factor pair that I had at the very end is the factor pair that I'm going to use. Now the way this is going to work is you have experienced by now when you FOILed problems in the previous lesson or you multiplied a binomial times a binomial, you traditionally got a trinomial as your answer. So most trinomials are going to factor down into 2 binomial pairs, or into a binomial times a binomial. So the first term is the easy term because it's x squared. There's only one way to get x squared, and that is x times x. You can think of this process as a reverse FOIL. Now I need factors of 16 that add to negative 8, and I have already discovered those. So it's negative 4 and negative 4. So I put negative 4 and negative 4. This is my answer. x minus 4 times x minus 4. The nice thing about factoring is you can always double check by foiling your answer, or multiplying your factors together. So if I FOIL this, if I go x times x, I do get x squared. And if I go x times negative 4, remember the O of FOIL is outers, I'm going to get negative 4x. If I do my inners, negative x times 4, I get another negative 4x. And finally, if I go negative 4 times negative 4, that is a positive 16. Combine my two middle terms there because they're like terms. And that checks out. I got what I started with, x squared minus 8x plus 16. That's my original problem. Therefore, my answer of x minus 4 times x minus 4 checks out. So now let's look at these problems and see if we can do this. You don't necessarily have to make a list. Sometimes you can simply look at the problem and make the decision. So on this one, we know that it's going to break down into two binomials. So I always start off by just putting in my parentheses. Now I need factors of 30 that add to negative 13. So when you think of 30, and I usually don't even think of the signs to begin with. So if I'm thinking of factor pairs of 30, I've got 1 times 30, 2 times 15, 3 times 10, 4, 5 times 6. You know you have all your factor pairs when your numbers start repeating. So I tend to start off 1, 2, 3, 4, 5, 6, 7, and then once I start repeating factors, I know I'm done. So these are all my possibilities. Which factor pair could I possibly get a negative 13 out of? Well, that would be this pair right here, 3 and 10. So the way that I could possibly get a negative 13 is if both my 3 and my 10 are negative. So let's start off. Our first term is going to be, well, it's t squared, so I would have t and t. It's the only way we can get t squared. And then I'm going to follow that up with a minus 3 and a minus 10. Again, you can always check your work by doing FOIL, and you can do it mentally. So if you just go first outer, first would be t squared, outer would be negative 10t, inner negative 3t, and last plus 30. And your middle terms definitely combine. I encourage you to always check after you get done factoring. And so that will check out. T squared minus 13t plus 30 factors into t minus 3 times t minus 10. So there's your factor pairs. So now let's try the next one. We have p squared minus 5p minus 14. So we know it's going to start off with p times p. Now I need factors of 14. So factors of 14, so that's 1 times 14, 2 times 7. It's the only way you can get 14. So I need factors of 14 that add up to 5. Well, the only pair that I might be able to get that to happen is the 2 and the 7. Now notice I need a negative 5. So in order to get a negative 5 for the sum, then I know that my 7 would have to be negative, my 2 would have to be the positive. So when I come over to put them into my factor pairs, I'm going to do plus 2 and a minus 7. Again, you can check by doing FOIL, first, outer, inner, last. So if we do our check step real quick, I get p times p, which is p squared. I would get my outers. P times negative 7 would be negative 7p. My inners would be 2p. And finally my last would be negative 14. My middle terms would combine. And I'm left with p squared minus 5p minus 14, which is my original problem, which tells me that my factors of p plus 2 times p minus 7 is the correct answer. Two more, and I want to do these two because they look a little bit different than what we've been doing. So the first one, this one actually starts off with an x cubed. We haven't done one of those before. So I've got x cubed minus 3x squared minus 40x. Hopefully you notice something. Hopefully you notice that all three of these terms have a GCF. You should always look for a GCF first when you're factoring any problem, and if it has a GCF, then we're going to factor that out. They all have an x, so I can start off by factoring an x out. So that leaves me x squared minus 3x minus 40. Now I can break down this trinomial. I know both binomial terms are going to start off with an x. Factors of 40. So let's think of factor pairs of 40. So 1 times 40, 2 times 20, 3 doesn't go in, 4 times 10, and 5 times 8. To get a negative 3, the only pair that's going to work for that is going to be the 5 and the 8. I'm going to need a minus 3, which tells me my negative will be on the 8, and my 5 will be the positive. So when I come over into my problem, I'm going to have a positive 5 and a minus 8. And again, you can always double check that. By now, maybe you've noticed you really don't have to do the whole FOIL process. You really just need to check your outers and your inners to make sure those combine, because we already know that the x times x is going to be x squared. That's where we got those those variables from. We already know that 5 times 8 is going to be 40. What we really have to check is that the outers and the inners combine to be that negative 3x. So my outers, it's a negative 8x. My inners is a positive 5x. So does that combine for the negative 3? Yes, it does. So my final answer is x times x plus 5 times x minus 8. So this problem had actually 3 factors involved. Don't forget that original x that we pulled out for the greatest common factor. And finally, our last example, we have 16x plus 60 plus x squared. Hopefully you notice this one looks different because things are in a weird order. So the first thing you're going to want to do with this problem is rewrite it. We like for it to be in descending order, so I'm going to rewrite it with my squared term first, then my x term, and then my constant. Now I can break it down. X and x, factors of 60 that combine for, or factors of 60 that combine for 16. So let's see here, I've got 1 times 60, 2 times 30, 3 times 20, 4 times 15, I'm running out of room, and 5 times 12, and 6 times 10. I believe that's all of our possible pairs. So how can I possibly get 16? Well, if I use the 6 and the 10. So let's put in a positive 6 and a positive 10, and that should be our final answer. If you do a mental check of your outers, my outers would give me 10x, my inners would give me 6x. We are good. X plus 6 times x plus 10.